Hey everyone, my name is Nick and welcome to the Topology Crash Course. In this first episode, I will help you understand the core principles of topology as well as how it affects your 3D models and renders. Before we get started with the different types of topology, we need to understand what topology means. Now imagine you have a paper cube in front of yourself and you want to disassemble it. You want to unfold it into 6 squares, right? Just like this. This is the exact same principle as topology, except topology obviously gets a lot more complex, but the core concept is the same. By definition, topology is the way in which constituent parts are interrelated or arranged, which essentially means in which way all the shapes are connected and arranged together. So now that we have an understanding of what topology means, let's take a look at the different types of topology and see how they can affect your 3D models and renders. First of all, we have the triangular topology. As you might have guessed, it consists of triangles. It is often found in 3D scans, CAD models, and spherical surfaces. Like every type of topology, it has its pros and cons. For example, triangle polygons work really well for spherical shapes and 3D scan models. This is because triangles require 3 points to create a polygon, while quads require 4 points. With 4 points, you can make 2 triangles or only 1 quad. This allows a greater amount of detail for the same amount of photographic data. However, we will later see how we can retopologize triangular topology into quads. Now, the main con for triangle polygons is their unpredictable nature. Here, as you can see, I have a simple plane which is 3 by 3. If I try to make a loop selection on this plane, as you can see, it's very simple. The software doesn't get confused and it can easily select loops in the direction you want. However, what happens if we introduce a triangle in the middle? I'm going to take the knife tool and cut the middle square into 2 triangles. Now, if I try to make a loop selection, it creates a mess. As you can see, the software gets really confused and it can't properly select the loops. It works fine on the edges, but as soon as you try to select the middle, it creates some weird shapes. This happens because the flow is broken by the triangle. Most of the mesh consists of squares and you have a triangle in the middle. What happens is, when you try to make a loop selection, you want to direct your polygon flow. So when you take the loop selection tool, you want to make, for example, a loop selection that goes around the corner here. If you make the selection, it's going to start from the middle, go into this polygon over here, and now it's no longer a square, it's a triangle, right? So the flow is going to go into this polygon over here, and now it has 2 equal options, either to go straight or to go left, right? Having these 2 identical options confuses the software because there is no longer a clear path. The software doesn't know which way to go. So even if we wanted to go this route into this polygon here and continue our loop, the software doesn't know that. The software continues its mathematical path and goes into this polygon over here. Now, how can we fix this? It's pretty simple. What we can do is split this triangle over here into 2 small triangles. That way we will be left with a quad here and 2 small triangles. So how we can do that? We can take the knife tool, cut across. Now we have 4 triangles, and we can delete this edge. And now, if we move this circle over here, as you can see, we're left with a quad over here, which is 4-sided, and 2 small triangles. Now, if we try to make a loop selection, as you can see, the software clearly knows the path we're trying to go. And that's because when we input our selection, for example, we start at the bottom here, the selection goes into the polygon, and now it has 2 options, either to go to this triangle or to go into this quad. Since it's already located in a triangle, it's going to prefer this route, and it's going to go into the triangle and then to the next one. And here the choice is clear because you only have 1 quad and it can only go straight. Having the topology set up this way forces the software to make the selection you want, because it doesn't leave another option for the selection. Now what if we want 2 symmetrical loop selections? That's pretty easy too. You go into point mode and you cut this back into 2 triangles. And now if you're trying to make a loop selection, as you can see, it either selects this path or this path. Like we saw previously, it's going to prioritize one of the 2 ways. So it's going to go in this polygon and follow its designated path. Same thing goes for the top here. It's going to go into this polygon, this one, and follow its path. Later on in this course, we're going to see several tricks that allow you to direct the polygon flow like you want it to. Just like I mentioned before, triangle topology is also found in 3D scan assets. As you can see, this model is entirely made out of triangles, and that is because the reason I explained earlier, the photogrammetry software can make 2 quads for each 4 points, rather than 1 square, thus giving us more detail for the same amount of photogrammetry data. For the second type of topology, we have quads. This is considered the best type of topology because it's predictable, easy to work with, and makes it very easy to create UV seams for texturing. However, just like any type of topology, it has its cons. For example, if I bring up a sphere over here, you can see it's entirely made out of quads. Now, if you look closely, you can see that we start with some perfect quads in the middle, and when we make our way at the top, you can see they're no longer perfect quads, they're more like rectangles. And if we continue to move up, you can see that in the middle here, they're no longer quads. In fact, this whole top area over here is made out of triangles. And that is because we have only 1 point of contact at the top and 2 at the bottom. So inevitably, it's going to create triangles. This might not seem like an issue, but what if you want to make a loop selection across the top? If we try to do it horizontally, as you can see, it's not a problem. But when we try to do it at the top, as you can see, our loop selection breaks and it only connects at 1 point. This will result in some stretching when you try to texture your model, because you go from 2 point of contact to 1 and then back to 2. Now, I mentioned earlier that triangles are really good for spherical surfaces. Let's take a look at this exact sphere, but instead of quads, it's going to be made entirely out of triangles. Here, as you can see, it's the exact same sphere, but now it's made entirely out of triangles, and the cool part is, all the triangles are distributed evenly. If you remember with the quad sphere, over here, let me bring it to the side, you had some noticeable stretching at the top and some triangles on the top area. However, with the triangle sphere, all the polygons are distributed nice and evenly across the whole model. And no matter how much you subdivide the sphere, for example, if I go back and I try to subdivide the sphere even more, as you can see, the distribution of polygons remains exactly the same. That's because the initial distribution of polygons is even, and then it just keeps subdividing triangles into more triangles. So even if I put 100 samples, as you can see, they're all pretty much the same size and distributed evenly. This is also the reason spherical constructions are built this way. That's because it can distribute the mass evenly. Now, for our last type of topology, we have n-gons. N-gons are shapes that have more than 4 sides, meaning 5 sides and more. Now, just like triangles, having n-gons in your quad topology results in some very messy selections. As you can see, it can create some pretty ugly shapes, and generally it's really hard to work with. Usually n-gons are created by mistake, but sometimes when you model, having some n-gons is inevitable. Later on, we're going to see how to avoid them, and if in some cases we're absolutely forced to use them, how to use them correctly and how to direct our polygon flow accordingly. But in general, you should try to stay away from them. Now that we understand the different types of topology, let's see how they affect our 3D models and renders. So for our first example, I have a CAD model which I imported into Cinema 4D. As you can see, the topology is made entirely out of triangles and it's very messy. If I select it and try to make a loop selection, as you can see, it creates a total mess. It's virtually impossible to work with. If you want to make polygon selections to apply textures or create UV seams, it's a nightmare. Unless you're using procedural textures or it's a photogrammetry asset, I highly recommend doing retopology on assets like this. Right next to the CAD model, we have the same model over here, but I did some retopology to it. As you can see, it's now entirely made out of quads, it's symmetrical, and there's a very nice polygon distribution. If I select this model and I try to make a loop selection, as you can see, it's really easy. The software doesn't get confused, and you can make some really simple loop cuts and loop selections around the model. This makes it very easy for texturing, and if you want to make some UV seams, same thing goes for the edge selection. Very easy and straightforward. Now you might ask yourself, well, that's cool and all, but how can it actually affect our renders? What's the difference? So in order to illustrate that, I'm going to apply a simple octane material to our model, and we're going to see exactly how it affects reflections. I'm going to open the Octane Live Viewer, start the render. Now, as you can see, we have our two models. Let's apply the material. The first thing we notice, if we take a look at the CAD model with the bad topology, there's some very noticeable stretching happening on the side here. It's not visible in the live viewer because it's a procedural texture, but you can see on the front it looks okay, but when you look at the side, it's very stretched. This will be very noticeable when you try to apply some textures to it. Now, let's see what happens if we subdivide both models. As you can see right now, it's pretty low poly and you can see the edges. So let's subdivide both models. And now we can start to see even more problems. As you can see in the reflection over here in the highlight, the surface is really rough. You can see a bunch of small bumps. On the sides here, you can see there's creases. If you look at an angle, it's even worse. We have some stretching going on over here. As you can see, there's streaks. That means there's pinching in this polygon over here. Now, if we look at the retopology version, everything is silky smooth. There's no imperfections, there's no pitching. The reflection goes straight around the model. Everything is perfect. These imperfections on the CAD model happen for the exact same reason as earlier. The topology is very messy, and if you try to make a loop selection, the software just doesn't know where to go, and it does the exact same thing for reflections, as you can see over here. So now that we understand the different types of topology and we know how important they are and how they can affect our 3D models and renders, let's jump in episode 2, in which I'm going to show you the different tools inside Cinema 4D that can help you achieve good topology in your 3D models.